will actually do RAID 4 and RAID 5. We'll get into what those are shortly. He's kind of already, Christoph touched on what some of the levels are, because you're striping, you stripe your data across disks. Similar to that I didn't write up on the board, is a RAID level called linear. I don't know how specific it is to Linux, but Linux does support it. And that's basically a concatenation, where you have one hard drive and you RAID it to another hard drive, and instead of alternating the writes between those drives, it'll fill up one disk and then just go on to the second one, but they still both look like they're one big disk. RAID 4 is sort of striping with parity. So you have 4 hard drives, you write data to one, you write data to another, you write data to a third one. Each time you write, it performs a checksum across all of those stripe areas and writes a parity section to your 4th disk. No live data that sits on that parity disk is always for a checksum. So that if one of your drives fails, that checksum can be used to recreate the data and you're still up and running. And I'll get into some of the benefits of different levels over the others.
Can I just ask real quick, who's not familiar with parity? I'll be glad to give a little 10-minute what parity is, and they'll show you on the board after we're done here. So if you want to hang around, I'll be glad to answer that question quickly. It looks like I like a jazz team.
Yeah. IBM drew the pictures of the first disk drives back in the 60s, and it's stuck.
It's like oil drums. Okay.
They work. So you've got a 10 gig drive and a 10 gig drive, and you're going to use RAID 0 to strike those. They're now connected in that you're going to write one block of data here, the next one you're going to write here, the next one comes back to here, the next one comes back to here. I don't know what the upper limit is, but you can strike, several disks in a row and get better performance and more disk capacity than in a single file system. So having a 10 gig drive striped with a 10 gig drive is going to give you 20 gigabytes of actual usable space. But what that doesn't give you is any kind of redundancy or fault tolerance. Mirroring, RAID level 1, also in this example we use 2 drives. However, when they're connected and it writes a block, it also writes a block over here, so that both disks now have the identical data written at the same time and committed by the operating system at the same time. The next block is going to get written here and here, and so on. So if you have those same 2 10 gigabyte drives, you don't get any additional capacity. Your usable capacity is only 10 gigabytes. But now you have that fault tolerance. If one drive fails, you still have all of your live data on the second one. And no data is lost, and you can hot swap drives. I haven't tested this, but the recent versions of the RAID tools imply that you can hot swap a drive out, put a new drive in, and have the tools recognize the new drive and resynchronize the data between the good mirror and the brand new drive.
The RAID 1 mirroring is your optimal security. You've got the exact copy of the disk. Disk fails, you still have the same disk. But it's awfully expensive because if you have a lot of disks, you've got to have twice of your data. You've got to have twice the capacity. Hence the next version of the RAID that he's going to talk about. The objective here is to produce less reliable redundancy, but you're basically getting better bang for your buck.
In RAID 4, we introduced what's called a parity disk, where when you write a block of data here, it calculates a checksum here so you can recreate this data if this drive fails. The second block of data would get written here, third here, fourth here, and so on. Anytime a write is done, checksum is performed across all of the stripes in the RAID 4 disk set, and a sum is written here so that if this drive were to fail, you can use this checksum and the data on this drive or as many other drives as you have and recreate whatever it was here so that no data is lost. And using the 10 gigabyte example, each of these 3 is 10 gigabytes. This is live data, this is live data, this is strictly for parity for data recovery. So you're given 20 gigabytes out of the 30 possible total usable space.
Think of parity as kind of like odds and evens.
Yeah.
If all your data is ones and zeros, which it physically is, each data block is basically lined up with the block in the next box and says this one's 1, this one's 0, your parity is 1. If my data blocks are all zeros, my parity is 0. If I've got two ones, it's 0. So basically, you're calculating odds and evens. So if you lose a disk, if you do your math, you can recreate a disk by recalculating the parity because you've got basically two knowns and one unknown. That's standard math. I hope.
Does that option have a performance loss compared to number 2? Does it take time to recreate?
Here's the deal. I mean, RAID 4 is something that the network appliance uses. They do it in hardware. It's all front-ended by an enormous amount of cache. Performance of the actual RAID calculation is negligible because your box is communicating with the cache. So you do it all in software, yeah, there's a huge penalty for it.
There's going to be a performance hit on two levels, because not only are you calculating the checksum, but you're having to hit this one drive for every write operation that goes out, no matter what drive it's actually touching. So you could hit a bottleneck by doing all of your parity calculations to this one hard drive. Which brings us to RAID 5. RAID 5 is that same parity concept, only it's distributed across all of the disks. As you write your data out, one of the slices across is your parity slice. So that the data chunk will be written here, and the parity calculation will be calculated in this one area of this first disk. When you write another chunk, or another chunk, or another chunk across this slice, this one section on the second drive will, for example, be the parity section on this set of slices across all 4 of your drives. This is now the parity section. So you don't have that single hard drive bottleneck of calculating your checksums all going to one hard drive. You now have that distributed. For this type of RAID, 5 is by far the most popular.
Let me interject one quick point. RAID 4, newer versions of RAID 5 allow you to grow and add disks to them, but that's only happened in the last couple of years. If you want to add a disk to a RAID 5 set, the usual procedure was to take all your data off of it, rebuild your RAID 5 set, and then dump all your data back on. That's kind of changed a little bit. RAID 4 has a nice feature of if you want to add a new disk to it, you just put zeros all over your disk because that doesn't change the parity. Once the disk has been zeroed out, you add it to the RAID 4 set, and now it just becomes part of your data structure. So it's real easy to grow your RAID 4 sets. In the past, it was impossible. I don't know if you can grow RAID 5 in software. It's typically a hardware thing where they migrate your data around and then insert stuff into them. I'm not all that familiar with it.
I don't believe the RAID tools allow you to grow.
Has anyone ever experienced data production with RAID 5?
Yeah. The one problem we run into, especially with RAID 4 and 5, is that you are protected against a single disk drive failing. If you have 2 disk drives fail, you're dead in the water because you've now lost the live data and the parity calculations, so you can't recreate what data was on the drive that you lost.
RAID is not really a replacement for backups.
No.
That's why I had it as 2 separate topics in the whole enterprise discussion. Backup is its own category.
Yeah. RAID will protect you from periodic data disks and periodic hardware disks to a specific disk drive. Again, if you lose 2 drives, you've lost your
It's
data.
all a lottery game. I mean, the goal here is to improve your availability. And the likelihood of you losing 2 of the same disks in the same RAID 4 or RAID 5 set are very minimal. Obviously, if you build a RAID 4 set with 100 disks in it, your chances of having 2 disks fail in the same general vicinity are more likely, especially if they run for a long time and you've never replaced any of them. There's a good chance at some point they're all going to start failing around the same week. Especially if you have a data center power failure or something like that. The disks spin down, I bet you 50% of them don't come back up.
So that's where you're.
Especially on buying and stuff. And this also doesn't protect you against somebody actually deleting their entire drive directory. And it's very uncommon, but one disk drive failing can take out an entire chain. It's, again, very unlikely, but some sort of power spike or something along those lines. Could take out more than just a single.
Every hard drive's got a little bit of logic chip in it. If that logic chip is ceased to go, it could just turn a wire on the bus on and leave it on so that no other disk can talk. I mean, usually it's the mechanics of the hard drive, head, motors, it's those things that fail. But anything can fail on the hard drive. So again, when you're planning good storage management, you've got to split your disks on different buses. You've got to mirror across controllers. Don't just mirror your disks on the same controller. Because if this disk goes bad and it takes the whole controller with it, this controller is still going to be safe. It's unlikely that this damage is going to spread across the motherboard and impact this guy. But these are all the things you want to consider when you improve the redundancy on your system.
Especially if you're going to try this on a PC, put your two IDE drives on the separate IDE controllers. If you put them on the same controller, you can tell it to do some operation, go have lunch, and then come back. In particular, write performance to two ATA drives on the same controller. You don't even need to be using the word performance at that point. Yes.
Might as well running Windows NT.
Is there a difference in the performance hit and the rebuild between 4 and 5? Because you need some time to rebuild from parity.
I believe you have better performance rebuilding of 5 because your reads are going to be distributed across the disks, as opposed to all the reads coming from your one drive.
So can you get to that bottleneck?
Right. Again, you're getting away from the single parity drive bottleneck. Yeah.
And that's the rebuild time on RAID disks is a serious issue because as vendors start to deploy 36 gig, 90 gig, 180 gig drives, rebuilding a disk can take hours, even on high performance systems, and those are hours which your RAID volumes are exposed. So if you do have another failure, these are things you have to consider. Do you want to buy a giant storage box with 180 gig drives on it? Because the likelihood if you have one fail, and now you're being basically exposed to a second drive failure scenario, could be hours as opposed to minutes if you get 18 gig drives. Yes.
When you rebuild, you're going to have to read all the data on all the remaining drives. There's no way of getting out of that.
Correct.
It's not just the parity drive you're going to read, it's the whole set.
Right, because you have to compare that parity data with the rest of the data on the drives that are still good in the RAID set in order to calculate what needs to go on the new drive. Correct.
So if you do this while you're up and running, the whole point of it, it just kills your performance as you're
Performance will noticeably slow down, yes.
In most cases, RAID 4 and RAID 5 are implemented in hardware. You're paying for external hardware not built into your system, unless you're getting like a special controller. But technically, you're paying EMC, Sun, IBM, Compaq. You're paying one of those guys to sell you a box that does all this in hardware so that performance penalty is kind of hidden behind the cache. But even then, you're going to get considerable degradation of services when the system's rebuilt.
The better hardware also has a throttling function. So you
Yep.
can say, I only want to give 30% of the bandwidth over to the rebuild.
You almost have the capacity to give it a nice level,
Yeah.
a nice 10 in the rebuild, and then it just doesn't take hours, and it takes days.
Yes.
Speaking from experience, right? How do you calculate the capacity of the RAID 5 then?
So you lose one drive.
You basically lose one drive to parity. Yeah. Because one slice as you go across your disks is going to get lost to the parity, eventually all adding up to one physical hard drive. So out of 4 10 gig drives, you're going to end up with 30 usable gigabytes of data. Now, I'm going to talk about a combination of 0 plus 1. There's a number of combinations. This is just one of the simplest. 0 indicating that your first one is striped data across drives, and then 1 indicating that you're going to mirror two striped sets together. So these are our first 2 striped sets, and we write a data block here, and a data block here. And this is another striped set together. That same first data block is going to get written here, and that same second data block will get written here. Now, because these are striped, these give us a usable total of 20 gigabytes